A few important points about this exponential model. Okay, now first of all, notice that C represents the initial amount of the quantity. All you have to do is put t equals 0 on the right hand side. You'll notice that you end up with C times e to the 0, which is C. Okay? So C represents how much we start with, assuming of course that we start at time 0, which is the normal assumption that we make in these kind of situations. The other thing is that K can be interpreted as the rate of growth from the initial ODE. If you look at the initial ODE, K is the ratio between the rate of change and the quantity itself. So it's sort of a relative rate of growth. Okay? And it is in fact often reported as a percentage. We're going to see in examples how that works out. The other thing to notice is that if K is positive, then of course the rate of change is also positive. We're talking about a quantity Y, so that's itself is going to be positive. And so that means that the whole thing keeps growing more and more, and so we're talking about a growth process. On the other hand, if K is negative, then the rate of change is going to be negative, and so we're talking about something which is getting smaller and smaller, and we're going to talk about a decay process. So that means that we can apply this exponential model not only in the case of population growth or growth of other kinds of quantities that change in a similar way, but also in decay processes, and the stereotypical one, of course, is radioactive decay. Here are some familiar concepts coming from an exponential process or a growth and decay process that you may have seen in high school, but probably in a physics context. Okay, so here they come up again in this mathematical concept. First of all, if you have an exponential model, we can talk about the doubling time. This is the time it takes for the quantity to double. Okay. So how much is that time? Well, remember, we're asking for the time it takes for the quantity to double. Remember that the initial amount of the substance is actually C. So we're asking how long does it take for us to grow this substance from C to twice C. Okay, so we're looking for this time, capital T, for which 2C is going to be equal to C e to the kt. Well, notice that now the C can be cancelled, which means that the initial amount doesn't really matter. Okay, and once we cancel the C, we can easily solve that equation. Take the logarithm both sides and divide by K, and we end up that the doubling time is actually equal to ln 2 divided by the proportionality constant K. On the other hand, we can talk about the half-life for a decay process. Of course, this is the time it takes for the quantity to be halved, to remain half of what you had to begin with. Same process, we're asking how long does it take for the initial quantity C to become half of what it used to be. Same process, we take the logarithm, first of all we cancel the C, then we take the logarithm, then we divide by K, and we end up with minus ln 2 over K. One little interesting exercise for you to do is to check that this doubling time actually, and the half-life do not depend, what we're already seeing that they do not depend on the initial quantity, but show that they also do not depend on the initial time. So in other words, if instead of starting at t equals 0, we start at some other time, the time it takes for the quantity that you begin with, not at t equals 0, but at the new time that you choose as the starting time, still is going to be exactly the same. So it's again a good exercise for you to do in order to understand a little bit better how this process works. One little word of warning, on the other hand, you may have seen these two formulae in high school, and you may be tempted to use them in any kind of calculus question that involves half-life and doubling time. However, I will expect you always to find the required information from the model and the solution rather than just using a memorized formula. That's because I want to make sure that you understand the process and you understand how to work with it.